All right, use the diagram to solve the right triangle. Solve for angle A. Okay, so here's angle A. Okay. Remember, let me go back to the chart. We're using trigonometry to solve for all of these things. This one I am given two sides, so I am going to set up a trigonometric ratio. So I'm going to look at what I'm using first. Hypotenuse, the opposite side, my adjacent side. What do I have things next to? I have a number there and a number there. So if I look at, sorry. So Katoa, O and H, I'm using sine. Okay? So the sine of theta equals opposite over hypotenuse. So the sine of A equals, my opposite side is 6, my hypotenuse is 7. Okay? And remember, this is when I have the sine next to it, that's when I have to flip it. A equals the inverse sine of 6 over 7. Okay. So A equals, and I'm just going to type that in my calculator. Okay. And I can show you, that's why it looks so weird. I can show you how to do it here, but if you have a different calculator, hopefully you've already asked me how to do it on that calculator, because pretty much every calculator can do trig ratios. Okay, so if you have a different calculator than this one, just ask how to find those. So I'm doing the inverse sine, the one with the -1, of 6 over 7. And I get 58.9. I'm just going to round up that up to 59 degrees. All right, looking at number 20, solving for JK. So the first thing I need to do is know where my variable is. So I'm solving for J to K. That means my variable is here. Okay. Then I'm doing the exact same thing. Okay. What do I know? Well, here's my angle. So my right angle, across from that's my hypotenuse. Across from my given angle is my opposite side. And what I'm solving for is my adjacent side. Okay. I'm only going to be using two of these. I need to use my variable. I need to use the one with the number. H, it's not a variable. It's not given to me, so I don't care about it. So I'm using my opposite side and my adjacent side. If I look up here at SOHCAHTOA, that means I'm going to be using tangent. Okay. So tangent of theta equals opposite over adjacent. So tangent of my angle is 64 degrees. My opposite side is 16. My adjacent side is x. Putting tangent over 1, I'm going to cross multiply. So I have x times the tangent of 64 degrees equals 16 times 1, which is 16. Then x is being multiplied by something, so I'm going to do the opposite. I'm left with x equals 16 divided by the tangent of 64 degrees. Being divided by, in my trig ratios, the tangent of 64, which is 7.8. All right, looking at number 21, same type of problem. I am now solving for JL. So again, I need to start with where's my variable going to be. So going from J to L, all right, it's this side here. So that's my opposite side. No, it's not. Across my right angle. Sorry, ignore all that. Across from my right angle is the hypotenuse. Here's my angle. This is my opposite side and my adjacent side. Okay? So again, what do I know? Or what am I going to use? I want to use my opposite side and my hypotenuse. Again, you can look up at SOHCAHTOA, but opposite and hypotenuse is going to be sine. So sine of 64 is going to equal 16 over x. Again, I'm going to put my sine over 1, and I'm going to cross multiply. So I have x times the sine of 64 degrees equals 16 times 1, which is 16. And again, I'm multiplying, so I'm going to divide by the sine of 64 degrees. So x equals, because those cancel out, 16 divided by the sine of 64 is 17.8, right? So it's very careful to make sure you have the right trig ratio, right? Because these are two very different numbers, about 8 versus about 18, right? So make sure you are using that right trig ratio. So we get 17.8 here. All right, the last thing we are looking at is our elevation, angle of elevation and angle of depression problems, our word problems. So we do have to draw our own picture, okay? So a skateboard ramp at a local park has an angle of elevation of 36.7 degrees. The height of the ramp is 35 feet. How long is the ramp? Okay. Sketch a diagram and solve. So, right, we always do this, and we always have our angle down here. So again, a lot of us are not doing this. You have to label what's where, otherwise it doesn't make sense. Okay, it's really hard to see what the problem is. Where is our ramp? This is the start of the ramp. This is the end of the ramp. Right? A lot of us are labeling things in the wrong place just because we aren't paying attention. As soon as I put things on it, we're able to easily see it. So let's do that ourselves. Okay? So what numbers am I given? I am given 36.7 degrees. Again, our angle for our angles of elevation are always down there. And the height of the ramp is 35 feet. Height always goes straight up and down. Okay? How long is the ramp? So where's my variable going to be? A lot of people see the word long and want to put it down here. But this bottom side isn't where my ramp is. My ramp starts here and ends here. The length of my ramp is there. Okay? So be very careful. Now let's label our sides. I have my hypotenuse, the opposite side, and the adjacent side. So, I have a number on my opposite side, and I have a variable on my hypotenuse. There's nothing to do with my adjacent side. So opposite and hypotenuse is sine. So I'm going to be using the sine of theta equals opposite over hypotenuse. So the sine of 36.7 degrees equals, why did it jump up there? That was really weird. I don't know why it moved. So the sine of 36.7 degrees equals, my opposite side is 35, and my hypotenuse is my x. Okay? So again, I'm going to put it over 1, and I'm going to cross multiply. So I have x times the sine of 36.7 degrees equals 35 times 1, which is 35. My last step here is just to divide by the sine of 36.7, just like we did in all our other problems. 35 divided by the sine of 36.7 degrees is 58.7. This is in feet. Okay. So the length of the ramp is 58.7 feet. Sorry, I was just looking that our numbers got off. That's okay. Let's look at number 23, I guess. A fireman is standing at the edge of a building looking down into the city and sees an ambulance 118 feet from the base of the building. The angle of depression of the fireman to the ambulance is 42 degrees. How high is the building in feet? Okay, so remember, these are the weird ones. The triangle I want to look at is always going to be shaped like this. Okay? But we often have things over here, right? So we have to create our box. Okay. So what do we have? A fireman standing at the edge of a building. So here's our fireman's going to be up at top. And sees an ambulance. So here's his line of sight. So here's the ambulance. The ambulance is 118 feet from the base of the building. So if the fireman's at the top of the building, the base of the building is here. Okay. So the ambulance is the ambulance is 118 feet from the base. So ambulance base, this is 118. Remember, these are equal, so this is also 118. The angle of depression is 42 degrees. How high is the building? Well, the base of the building to where the fireman is standing is my x. So this is also x, right? It's a nice, lovely rectangle with equal sides there. Okay. So now I'm just labeling my sides. I'm solving my equation. I have my hypotenuse, the opposite side, and the adjacent side. So I have a number at my adjacent side and my variable at my opposite side. What uses opposite and adjacent is tangent. Tangent equals opposite over adjacent. So tangent of 42 degrees equals x over 118. Put it over 1. Okay. So I have x times 1, which is x, equals 118 times the tangent of 42 degrees. Right? And for this one, there's x is already by itself. I just have to type that into my calculator. And I get 106.2. 2 also feet. Great. Okay. One thing to note about these last two problems. These pictures are hard. I understand that. Draw a picture, label the picture, solve the problem. If your picture is wrong, you will lose a point. However, if your work is all correct based off the picture you drew, you will still get 2 points. Okay? So if you draw this nice picture, but things are not in the right place, but then you do all the rest of the work correctly, you're still going to get 2 out of the 3 points. If you don't label a picture and you just set up a wrong equation, you're not going to get any points because I don't know where your error is. Okay? So no matter what, draw a picture, label your triangle with where everything is. Okay? So that at least, even if it's wrong, you're still going to get the points for doing then the math work correctly. Okay? Other than that, look over target D, and then we will take that test.